Right, welcome back. So in our next examples, we're going to look at how we can add and subtract sets which are in the form of a rational number, right? So they are in the form of fractions. All right, so let's take an example, quick one. Assuming I have 2 root 3, right, over 3 plus let's say 4 root 3 over 2 minus root 3 on, let's say, 2 again. All right, so there we go. We are adding and subtracting sets with denominators, right? Now the key thing here is to look at the denominator. Is it a set? And when I say a set, I mean, is it a non-perfect square number that has square root on it? But then when you look at these numbers, they don't have square roots on them, so they are not sets, right? So, and in math, all the time when you are adding fractions, so this is in the form of a fraction, right? You have to find the LCM. So we have to find the LCM of our denominators. The LCM of 3, 2, and 2, that should be 6. All right. So we find out 3 into 6, how many times? 2 times this over here, right? So, and basically, just like in algebra, you have 2x times 2. That is the 2 that you're going to multiply the 2 by, right? So it's the same thing we're going to do for this. 2 root 3, that 2 is going to multiply with the coefficient. So 2 by 2, that gives me 4 root of 3, all right? Plus 2 into 3 into 6, that's 3. 3 is going to multiply with the coefficient of the root 3. That's 4 times 3, that's 12 root 3. Minus 2 goes into 3 6 times. 6 times the coefficient of root 3 here, that's 3 times 1, right? That's roots of 3. So now I have a common denominator, so I can comfortably add my numerators and subtract them. So I have 4 root 3 plus 12 root 3 minus 3 root 2. All right. So we saw from the earlier examples that we're going to have to add the coefficients because they are like terms, right? So we add the coefficients of the term, which in this place is root of 3. Right, so we have 4 root 3 plus 12 root 3 minus root 3. So I know I'm going to add 4 to this 12, giving me 16 minus the coefficient of root 3 here. I forgot to write is 3 because 2 into this is 3, 3 times this is 3. So I have this plus this, 16 minus 3, that's 13 root 3, all on 6. All right. So I can choose to end here, or I can write 13. Since this 13 is multiplying the root 3, I can just use the 6, which is the denominator, to divide the 13, and then I keep my root 3 here. And this is necessary in cases where the numerator over here can be divided by the denominator. So for instance, if I do and I get 12 here, assuming this was 12, then it's necessary that you do 12 over 6. So 12 goes into 6 goes into 12 2 times. So then you have 2 root 3. And then also in examples where you have, for instance, let's say this is 14 and then the denominator is 4, that so if it's assuming it's 14 and the denominator is 4 root 3, this is going to go here 2 times, it's going to go here 7 times. So your answer is 7 over 2 root of 3. Yeah, so basically we've seen how to add and subtract sets in the rational form. Then in our next example, we're going to look at how we're going to multiply and then divide sets.